Hello. Hi, friends. How are we doing? Everyone full from lunch? Feeling good? All right, excellent. Thank you so much for coming to the first Azure Dev Summit. It's pretty cool, right? When we decided to do Azure Dev Summit, we said, no matter what we do, there has to be a giant green igloo. So we made a giant green igloo. It's beautiful. I feel like Portugal and igloos, they go together perfectly. But isn't this a pretty cool event? Have you ever seen an event like this with the blow-up rooms? It's pretty cool. It's very nice. My name is Scott Hanselman, and I'm going to do a talk that is it's the first time I've done this talk. So this is like a practice. It's not very good. So I want you to just lower your expectations now. When I talked to my boss and I showed him this talk yesterday, he said, "What are you doing? What is that? What is the point?" And I said, "Does there have to be a point?" And he's like, "Well, you got to sell AI, and you got a Copilot, and the Copilot, and the Copilot." And I was like, "Yeah, but can it just be awesome? Can you just do it because it's cool?" He's like, "No, you work at Microsoft. You can't be cool." But this is Azure Dev Summit. It's not a Microsoft conference, even though it has Azure in the name, so I can do anything I want. So again, lower your expectations. I've got a bunch of demos. It's very likely the demos will not work. Some of the demos are ridiculous because it's like, what are you doing? But I'm going to do my very best. As we start out, I also want to call out that this is a talk about the history of computing from someone who is well into their 50s. I'm over 50 by some measurable amount. I've been in software engineering professionally for almost 35 years. Is there anyone here in their 20s? 20s? A couple of people lying. I love that. That's good. Appreciate that. Anyone here in their 60s? 60s. Okay, so we've got a 20 to 50 range. I don't want, when I teach, I don't want this talk to be old man who shakes his fist at the cloud. Ah, cloud. But I also need you to understand that how I feel about computers, how I interact with them, my emotional relationship with computers is different than a 20-year-old's. That's not a good thing, that's not a bad thing, it's just simply a thing. So I don't want you to feel like there's ageism or like I'm old and you're not old. We're all computer people, but I think that there isn't enough history taught in computer science class. They make you learn old programming languages, but they don't talk about old computers. So sometimes you might be at work with a bunch of old people, and they might be saying, "Oh man, Commodore 64, oh, those were the days. Oh, ZX Spectrum, I loved it so much, it was great." And maybe you're 20 or 30, and you're like, "My first computer was a Pentium," right? And you feel like you maybe missed out. So I brought a computer here all the way from the US. I brought an Altair Mini. This is a replica of the computer that Bill Gates wrote Microsoft Basic on. This was when Microsoft was micro-soft Basic. And Bill Gates wrote Microsoft Basic, and he licensed it on this computer. And when you buy a computer like this, you get a manual. And you have to print the manual out, and it has a spiral notebook. It has two sides. So I want to... Paparazzi. It's constant. So I brought the Altair because I wanted you to think about that. That's, for a lot of people, where computers started. That was 50 years ago, 1975, right? And I was there before that. And the relationship that one has with a computer at this time was very interesting. 50 years ago, you didn't really own a computer. You would rent time on one, or you would buy one and you'd build it from a kit. Now this is a mini. The actual Altair is a little bit larger, but you can buy this at altairmini.com. I don't have any relationship with these people. And you can build it from a kit. You can literally solder it together and flash the firmware and learn how it works. And it uses a simulator. And there's a difference between a simulator and an emulator. An emulator is clock perfect. It's trying to be exactly the same. And a simulator, like this one here, will run all of the software, but I can make it faster. Because to load BASIC would take 7 minutes. And that would be 12% of my talk. Additionally, in order to load the bootloader, you know when you like start your computer and it says BIOS, press delete and you load up and you wait for the bootloader to start Windows. On an Altair, you have to key in the bootloader. So you have to get your manual out, you have to flip the switch, and then you have to set all the bits and go load 1 byte at a time. And the bootloader is 27 bytes. So you have to set, load, set, load 27 times. That would take a while as well. So I tend to have a lot of patience, but my presumption would be that you all would not have a lot of patience for that. So I'll show you demos that don't require doing that. But Hello World on something like this was ultimately blinking an LED, right? That's the moment. Hello World is, I got the light to turn on. I got voltage on that wire. So when you interact with someone in their 50s or 60s about computers and you talk about, oh, this website is taking like a minute to scale, right? Oh, this Kubernetes node only scales to 50. You're also talking to someone who was dealing with 4K of RAM, 4,096 bytes of RAM. It's just, it was luxurious. It was roomy. Like, what could you do with 4K? That's insane. It's a huge amount. And now I'm upset because my iPhone has 8 gigs, right? And Reddit is slow. So every generation of computing starts with Hello World. And we're in a moment right now where we're accelerating everything. Everything's about acceleration. And I don't really like that. We hear about business acceleration, computing acceleration, so I wanted to separate acceleration out from the things that I care about. And I wanted to call out that acceleration, whether it be business acceleration or computing acceleration, is a very simple concept that has to do with the amount of time between the idea in your head and getting the output. And this is where I show my age. Someone's like, you know, your kid can just get ChatGPT and they can say, make me Space Invaders. And then standing on the shoulders of 50 years of computing and hundreds of years of math and algebra and all the science of all these things, taking it from people who took a rock and infused it with lightning and made the rock think. And they're like, oh, this Space Invaders game sucks. Right? There's people in this room with master's degrees and PhDs in computer science, and now a kid can vibe code into production. When I was growing up, I was told, don't get in a stranger's car and don't take candy from strangers. And I got off at the Lisbon airport, I went to the 2nd floor, and a stranger showed up in a beautiful car and gave me candy and drove me to my... And I want to drive stick shift. I remember as I was 15, I was building cars in my dad's garage. So someone would say, well, you're gatekeeping Uber. You're saying that people shouldn't be able to Uber. I'm not saying that. I'm saying that my relationship with the vehicle is fundamentally different than yours because not only can I change my own oil, not only can I change my own tire, not only can I rebuild an engine from scratch, but I can also build a bow and arrow from, like my dad does traditional Native American archery. So he goes out, finds a tree, strips the tree, builds the bow, takes the bow, bends it, stretches it, it takes months, goes out, doesn't shoot with a gun, shoots the deer, cleans the deer, brings the deer home, we put it in the freezer, and we have meat for a year. I grew up doing that. There's not a lot of software engineers on The Walking Dead. They did 7 seasons of that show. At no point did they need the router rebooted. Right? We're all dead. Those are the fast zombies. They've killed you all. You guys are useless. You have no ability. There are some people here that might have survived, but it's very likely that they had bow and arrow, abilities, and not like, the abilities that we have. My wife, actually, literally on the plane from Newark to Lisbon, there was a medical emergency. This really happened. We were eating our little, dry chicken on the airplane, and they said, "Is there a medical professional in the building?" And my wife is a charge nurse. She's a nurse manager. She handed me the chicken, and she put on her cape. She flew into premium economy, and I ate her food. And she was gone for an hour and a half. And then she saved somebody's life. She came back over. They gave her a $100 travel voucher. And I said, that was really cool. They said, is there a doctor in the house? And there is a doctor in the house, and she took care of it. And I said, did they need any regular expressions? Maybe, do some, I could count in binary with my fingers, No? Okay, cool. But I'm ready. I'm ready for the moment when I will be called with my skills. So that point about Uber is important because we want everyone to learn to code. We want people to understand how to interact with computers. But at what point is it too much? You call a stranger on a pocket supercomputer using radio frequency over a multi-node network, an intranet. You connect with a stranger, and you're lifted up, and you're brought to a location. If you have a disability or mobility challenges, that's amazing. But at what point are we going to get in capitalism where, I really want a taco, and then a drone, an Amazon drone, brings the taco and drops the taco directly into your mouth? And you're like, can someone move my jaw for me? At what point is Uber Eats and DoorDash just a little too much? These are all good things, but also at the same time, there's value in knowing how to cook. I don't want to grow kids. I don't want to raise children that can't change their oil and can't make a taco. They can only survive if DoorDash and Uber exist. So I think about computers in this way, but I want to find a balance because I want people to enjoy JavaScript and React, and I'm not saying they should learn assembler, but maybe they should sit in a 1-hour talk and appreciate how far we've come because it's not been 100 years. When I was a kid, we had computers like that, and now we have fake TikTok with AI videos. Yay, capitalism, right? Learning is what we do. Acceleration is what the computers do. But I am worried that we're not paying attention. If you let Copilot do everything, you're not paying attention. So I'm using Copilot to learn faster. It's accelerating my learning, and it's also letting me do things that I couldn't do before. Some of the demos are crazy. The final demo was a stupid idea. It's a stupid demo, but I couldn't have done it without Copilot. Now, in 1975, computing was a very physical act. There was even no operating system. You would key in the bootloader. There was no UI. This device here has output, serial port output. You would actually have to connect another device to it, a terminal. And for a time, the terminals that you would connect to an Altair had no screen. Some of you might know this, but for the younger people, I think this is fucking cool. How would you talk to a computer that has only lights? Anyone guess? Give me a 20. I saw some 20-year-olds. How would you talk to a computer without a screen? Someone under 30. It's not a quiz, sir. Morse code. Yeah, just slap the key. Yeah, that's actually a pretty good idea. Let me show you one of the ways that they would interact with a computer these many years ago. This is a JavaScript simulator of this device. So I can turn it on. You saw the lights just go on there. And I can hit run, and I can run different things. But check this out. That's how you would talk to it. The screen is the paper. It's 4K. So I'm going to load Microsoft Basic. This would take 7 minutes and 28 bytes. So we're going to save a little time. It's pretty exciting. Oh, this has got 5,000 bytes free. Holy shit, excuse me. So much bytes. You know what you do if you make a mistake? Anyone want to guess? You're screwed. You don't make mistakes. There's no mistakes allowed. The irony that I have a touch screen here. And I made a mistake. Dang it. Yeah, look at that. That's how we would play chess for hours. That was amazing. You'd play Space War, like Star Trek, and they'd print out the galaxy in dots. That was the screen. When they say terminal, when you're talking to the terminal, it's the terminal end of something, right? It terminates there. That is a TTY. That is a terminal machine on the other end here. Now, certainly, when they figured out how to make screens, it got easier, but that's literally how you would interact with it. You would plug in a serial port, and you talk to that, and that's your screen. And they would write BASIC, and then you would load them on, cards or cassette tapes. There's lots of different ways you could do this. Anything you could do to not have to type it in every time. Isn't that awesome? I think it's fucking fantastic. Now, there's no abstraction there unless you want one. So if you want to get down to the bits and the bytes, you can, and that's how you flash an LED in 1975. You set a bit, you set the output, you clear the bit, set the output again, and then you jump back to the beginning. So it says move 1 into A, output 1, move H into A, output 1 again, jump start. Makes it flash. Do you think that this would flash like this? How do you think it would flash? The speed of the what? The clock speed. The gentleman here just said, yeah, it probably wouldn't flash. I love that. He just said that's not going to flash. It's going to flash maybe 1,000 times a second because it's a 1 megahertz machine. That's probably going to look like it's on all the time. So you'd need to put in another loop to sleep to have it pulse if you wanted it to go and do things slower. So even that felt intuitive. It might have felt intuitive to you as well, probably. So the question is, I'm going to guess you're not 20, and you probably are 20-ish. Why do you both know? It'd be 29. 29. Why do you know that? Was it intuitive? Did you learn it in school? Why did that feel intuitive, that it did not flash slow? He's worked with LEDs before. Okay, this is super important, and I love this. We've got people who are 2 years apart in age. And he says he knows that because he's worked with LEDs before. Not because he didn't say I worked with old computers before. He didn't say I learned it in school before. He worked with LEDs before. And this is so important because the reason that junior engineers don't know stuff is that they never had the opportunity to know stuff. I'm not a good engineer. I'm an old engineer. There's a difference. I know stuff because I've seen a lot. And when I debug a problem and I do it like that, and my young coworkers are like, oh my God, you're so smart. No, I did that 20 years ago. I dropped a table in production, right? The way that you succeed in technology is you stick around for a long period of time. So the way that we build the next generation is we teach them this stuff. We teach them LED apps. We allow them to grow. So there's a moment here for the 40-something, 50-somethings to really teach the young people, because they're generating AI code and they have no idea what it does. I am really worried that we're going to have a window of about 5 years of ChatGPT engineers, and that window is going to kind of flow through the industry like a ripple of people that just kind of don't know how it works. I don't know. I went to the phone and the guy came and he picked me up in some magic wheeled chariot, and then he transported me and then the car disappeared. Where does he go? He sleeps and waits for me, right? If you don't understand the abstraction underneath, if you never had the chance to play with an LED, then that wouldn't be intuitive to you. So there's an opportunity for us. Now, moving forward, 1977, 1980s, BASIC becomes an abstraction layer because dealing with registers is no fun. So for most of us, I would say the majority of this room, we started there, right? Was that Hello World for you? 10, Hello World, go to. Maybe it was Visual Basic. Maybe it was regular BASIC. Maybe it was Commodore 64 BASIC. Maybe it was whatever. But that is so close to English that even someone that doesn't program can look at that and go, yeah, that's pretty cool. I get that. That makes a lot of sense. That was the moment when computing reached the house. Before, it was at the university, then it was at the larger schools, and then it went to your home. And then programs needed to be stored in a way that wasn't a cardstock. It was a cassette tape or a floppy disk or something like that. So for me, it was this. That was the moment. I'm going to talk more about this in my talk on Thursday, but my parents had a van, and they sold it, and they bought me a Commodore. One day I went home, the car was gone, and that was exchanged. And that blew my mind, because a car is big and takes you places, and this is small and takes you nowhere. But if that hadn't happened, I wouldn't be here today. Was anyone here a Commodore 64 their first computer? ZX Spectrum first computer? Right? A $200 or $300 computer brought to your home that let you type "Hello World" is how 90% of these experiences happen. So the question is, for the 20-year-olds, for the 20-year-old's 5-year-old kid, is it an iPad? Is it an Android? Is it going to be ChatGPT and hey, make me a Space Invaders game? What's their Hello World? And make me a clone of Doom, except my dad is the enemy, right? That's not Hello World. That's too much. We're making it too easy, I think. We want to teach people how this stuff works. Another thing worth pointing out, if we think about the operating systems on these machines, I'm going to go out to the command line here, and I'm going to go to this folder. You can't see my screen? That'll do it. Thank you for telling me that. Go out to the command line, and I'm going to run an Altair simulator. And if I can remember how to do this, I believe it is attach disk, CPM to disk, boot disk. Ooh, look at that. And let's run Microsoft Basic. Where's MBasic? MBasic ELIZA. Okay, this is the first AI. Did anyone ever learn about ELIZA in school? A couple people. This is a generational thing. ELIZA was the first AI, right? So, psychology. There's a psychologist. Hi, I am sad. My boss, Scott Hunter, is mean to me. Well, I told you that, bro. That right there was ChatGPT in 1977. And that's just a 5,000-line basic app. And there's been ports of it to different things. It's a trick. It's a trick because it repeats things to you. What's that?
I'm confused. How did you...
Are you blown away?
Yeah.
That's great. I love that. So for him, it's like, that's amazing. How can you do that in the 70s?
It tries to generate empathy, like using what you say and asking you again, are you like that? Are you sure?
Yeah, he says it's repeating stuff. So it's like, are you sad? I understand that you're sad. Why do you think you're sad? Right? I feel emotion. Why do you feel emotion? Well, my mom. Well, what can you tell me about your mom? It's a trick. It's a parrot. You guys know about parrots, right? They sit on your shoulder and your aunt or your uncle has one. You go, how's it going? How's it going? Right? It's a parrot. And parrots are interesting because when you see a parrot really talking for the first time, you're like, that's amazing. That parrot is so smart. That parrot speaks Portuguese. That must be much smarter than the parrot at my house that speaks English. No, it just speaks the language because it hears the language. This right here is a lie. Right? It's just flipping it around. People saw that and they thought it was real. People would spend hours talking to it. So the same thing that we see now, where people are using ChatGPT for a therapist, they would do this like that. And they felt that it was amazing because you would not be able to imagine there wasn't a person on the other side. But it was a tiny little computer, 1 million times less powerful than my watch, 10 million times less powerful than my iPhone. But it still is impressive, isn't it? It's amazing. And look, I can actually go and look, like you can go and look at the code. It's literally in eliza.bas. So if you want to see it, go explore the code in Eliza. It's a real thing. Yeah, that kind of stuff is very exciting, and that was happening 50 years ago. It was an illusion. So when you are being impressed by these kind of devices, when I feel like there's a performance issue, like this machine is slow, I remember what I was able to do on a Commodore 64, and I go like, there's no excuse. That should be faster. A Commodore 64 is what's called a 6502 processor, which is one of the only processors that was made in the 80s that is still made today. You can buy them for like 100 of them for $5. This is a Commodore 64 emulator. And last night, using ChatGPT, I thought it'd be cool to do this. Now, I don't remember 6502 assembler. So I instead vibe coded a C to x64, a C to 6502 assembler to compiler chain, and then used an open source compiler to turn that into a program that I can then run on a Commodore 64. I know the pieces. I know what to do, but I didn't want to worry about the details. But I can look at the code if I wanted to, which is not very exciting, right? Or I can look at the C code that you would probably be able to see. Draw Azure logo, stylized A, row 1, row 2, row 3. The best part about this is the go-tos. It's very low-level stuff, and it's super fun. And it's a great way to learn about history, and it's also an interesting way to remind yourself about what was possible then. You should be able to do at least that cool stuff now. I would argue that I spent more time in Bard's Tale than just about anything. And this was 50, 60 hours of my life over weeks with graph paper. We were captured by that. But now we're losing our attention span. But I would argue that that's a cool game even now. That's interesting. I could play that on a handheld. You could release that for iPhone. That would be fun. But all of these things were not connected. This is not a machine that lets more than one user attach to it. And when we wanted to connect to each other, we wanted to connect to learn. We didn't want to connect to do commerce. We weren't trying to make an internet. We just wanted to talk to each other, share code, and share notes. And there was no internet. So we made BBSs, bulletin board systems. In England and the UK, they had television channels that you would have. What was it called? The text? Any British people here? Say it again? CFAX. So it's like a TV that's broadcasting in one direction. We would also have radio stations that would say, we're going to play a game right now. And when we say play a game, we mean we're going to hit play, and it's going to start screaming the game as a modem. Imagine a one-way screaming. Get ready on your tape deck, your recorder, to hit record. And then you play, and it's screaming for 20 minutes. And then you hit stop, and now you have a recording of Pac-Man that you can then play back onto your thing. So a BBS was the first kind of distributed computing. If I wanted to send an email, I would dial you up. You'd have your computer listening on the other side. I would then send an email. It would sit on his computer until you dialed and picked it up. But if you were in another country, his computer would call your computer and it would bounce its way across Europe, making short calls and avoiding long-distance charges if at all possible. In the US, we had one called FidoNet. I think that also happened in Europe as well. And we would bounce the email from BBS to BBS as it found its way over the course of a day or two around Europe. And you would connect to a computer like this, a terminal. That's not a computer. That's just a screen. It's dumb. Remember that typewriter? That wasn't a computer. It was a typewriter. The computer was big. So I would have like a 386 or a 486. It was like this tall. And then you would go out there and you'd connect to something that looked like this. Actually, no. You connect to something that looked like this, right? And it would send that text over the net. And the result was this. And we could tell if it was going to be a good session or not. You could like feel it. You're like, that's a good connection. That one's going to be good. We're going to get a good connection. Or you would say, no, that didn't sound very healthy. I don't like that one. That one's not good. And those BBSs, excitingly enough, still exist today. You can go and do stuff like this. You can go out to the command line, like I'm going to do now. And we thought this was the greatest thing in the history of the world. You couldn't tell me nothing. Because we couldn't download a movie. We couldn't watch Star Wars. I can't go on the Usenet, or I can't go on Torrent. So this is Star Wars. And you can do this today. They've kept this up all these years. After this little part here, it gets more exciting, trust me. Now, this is actually very fast. When we were doing it, it would go like this. And you could almost feel it going by. Here's the best part. Get ready. The graphics are pretty amazing. Pew, 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 pew. Oh my goodness, Darth Vader's coming. It's the stormtroopers. So that was before we got color, which was even better. You can actually connect like this to a BBS, which I happen to make an account at. Here's my email. This is how we check email. And then we can go and see who's online. And we can play games. And then when they wanted to draw to the screen, they would do the best they can. That was pretty exciting stuff. So when we get back to how he learned LEDs and how you learned LEDs, how did I learn about TCP/IP, DNS, and ports? And why is it intuitive? Because we would telnet over to a specific port. And that was intuitive. And we were doing this 25, 30 years ago. So then how does a 20-year-old in school learn about ports and whether or not that process has a port open? Or whether or not we're listening to a port, or whether we're natted or double natted, or we're doing Kubernetes. So even though I don't know how Kubernetes works, I'm very confident that I could have an extended conversation in an interview about Kubernetes and how those networking ins and outs work, because we were doing that stuff. We were doing distributed computing 30 years ago, and I have a visceral, in my chest understanding of how networking works at the packet level. Some people here know how to use Wireshark, and some people here just browse, and that's okay. But there's value in just spending a weekend and learning about these things so that you can understand it at a deeper level. I'm going to go ahead and get out of this game. You have to quit, otherwise no one will be able to play, and you'll have that application stuck. Thank you for calling. There you go. There's a whole list of bulletin boards that you can connect to. The only difference is there's no dial-up. That's what the modem looked like. Here's a funny thing. In 1989, I was running a Wildcat bulletin board system in my parents' garage. In 2007, I went to work at Microsoft, and my boss, a gentleman named Scott Hunter, happened to mention over lunch one day that he wrote Wildcat BBS software. He was employee number 2 at Mustang Software. He just happens to be a couple years ahead of me, so he was like 19 and I was 15, and he was off writing that software that I was connected to. 20 years later, he's my boss. He made things like this possible. By the way, none of this is graphics. This is all just really good ANSI and ASCII art. And that's even an art style that consists today. So then we move to a time of open source where we're connected now. Why don't we start sharing stuff? That's where GNU and Minix is how I learned Linux. Minix is how Linus did Linux. I wrote my first operating system from a book. You had to buy the Minix book and type the source code in. And that's how you build your own operating system, build your own file system. So at this point, we start collaborating. I also happen to become a type 1 diabetic at this point. So I've been diabetic now for over 30 years, and I have a sensor right here in my arm, and I have an insulin pump right here. And you may or may not have noticed, as we were out at the command line, my command line is kind of blinged out a little bit with the current folder, the current Git repository, the fact that I'm on a dev drive, how long the last command took, and my blood sugar. That's real-time access to my blood sugar that's bouncing from my arm to Bluetooth to my phone to the cloud, into Azure, into a Mongo database that's being brought down via a REST API and dropped into my command line interface. Because I have a REST API for my own body. I recommend that we all get a REST API. That kind of plugging the Lego pieces together happens when you have all the different kinds of Lego in your head. And that's why it's so important to learn this stuff and how these things plug together. So I became diabetic. I want you to prepare yourselves. Look at that beautiful man. I missed that hair. You couldn't tell me shit. I looked good. I wanted the swoosh like Superman. That is me as a type 1 diabetic writing the first portable blood sugar management system in 1995. I also want to call out, we should probably ignore all of the soda pop on the back wall there. I don't know what's going on here. This is probably, I should not be drinking that. And I found my first web page from 1993. I showed that to my boss, and he's like, "That was a mess." That was Hanselman.com back in the 90s with the diabetes software for Palm Pilot. And one of the things that software did was it ran inside of 4K. And 4K, as you may or may not know, is not a lot, right? So I actually found that software and an emulator for it that I can now run a Palm Pilot. Put in blood sugar, and then do charts and graphs. That chart right there, being able to draw a chart like that, that was done on a Palm Pilot, a portable device, before we had iPhones. To this day, that was the most technical and interesting thing that I've ever done as a programmer. Because I said, I want to draw a circle. So I'll call the draw circle command, right? No, Palm Pilot doesn't have a draw circle command. That's fine. I'll just draw a line. There's no draw line. That's fine. I'll just draw a point. There's no draw point. You have to find in memory where the screen is stored, and you have to XOR over the bytes directly into screen memory and make your own draw point. Okay, that's fine. I'll make a draw point macro, but then I need to draw a circle. Well, I'll use the sine and cosine features of the math library. There's no math library on a Palm Pilot. That's fine. I'll write my own math library. I'll just use floating point. Well, it doesn't support floating point. It only supports unsigned integers. So that's fine. I'll just chop an integer in half, 4 bytes and 4 bytes, and I'll make this part to the left, on the left side of the decimal point, and this part on the right to the right side of the decimal point. All I wanted to do was draw a fucking circle. And I had to implement my own math routines, write cosine and sine. I was getting algebra books out in order to do that kind of work. And then, of course, by the time I finished it, they added those APIs. And then they came out with color. But all of this kind of stuff is exciting and fun, and you can still do that now. There are tools like Pico 8, Pico 8. It's a delightful little retro gaming tool. And if you've ever heard of the video game Celeste, which was the game of the year, it was on Xbox, it was on Switch. It was all designed in about 4K with a tiny screen like this in the 2020s on a tool called Pico 8. So it may sound like I'm just an old guy showing you small things, but there is interesting work happening in 4K today that's fun for kids, it's fun for adults, it's fun for hobbyists. They're applauding me. I love it. So then the cloud happens, and things start becoming infinite and elastic and disposable. We start throwing computers around and virtual machines around like they're cattle. We don't care about them anymore. We cared about devices like this deeply, but we did not care about a virtual machine. We'll put a virtual machine in the cloud and forget that it's there. I'll spin up a 30 gig Linux box and I'll be like, did I leave that machine running? Just like saying, did I leave the stove on or did I leave the iron running? I'll be like, did I leave that virtual machine going in Azure? That's going to cost me $3. Gosh, that sucks. And now, instead of hello world, with something like that, I can do this. I'm out to Linux right here. I'm going to hit Visual Studio Code within Linux, within Windows. And that's hello world in an Azure function. No virtual machine, no operating system, per second billing. And now it's per millisecond cycle, like CPU cycle billing. I could call this API like 1,000,000 times. It would cost me 3 cents. So serverless computing, they're still servers. You just think about them less. That's true. So then I can spin that up and deploy that very simply. And so now hello world moves from something like this to being infinitely scalable in the cloud. But I would argue people don't appreciate it. The operating system still exists. All of these concepts that I learned 50 years ago still exist. We should not forget them. I saw this Reddit thread recently that I want you all to see because God bless the young people, but they're doing some stuff that they need to not be doing. There it is. Check this out. This guy audited 74 startups' code bases. Month 1, everything is great. Month 7 to 12, things are slowing down. Month 13, you cannot add a new feature without breaking them. Month 25, rebuild from scratch. What did he find in 47 code bases? 0 database indexing, 8 times more servers than they need, burning tens of thousands of dollars a month, 0 automated tests. This is not old versus young. This is experience versus vibes. You can vibe all you want. Good software engineering was good software engineering 50 years ago, and it's good software engineering today. One of the things that I thought was really interesting about this thread was the gentleman said, or the gentleman or the lady said that he or she found that they were running 40 servers when they needed 6. And by fixing it up and adding some database query indexes, they saved almost $40,000 a month. Now, again, I'm not a good programmer, but I'm lazy and I'm cheap. So Hanselman.com gets 1 million page views a month. The blog, the podcast, and Azure Friday are all running on one Azure App Service plan that costs me $43 a month. Why? Because I looked at what Azure offered, and I said, I've got 4 gigs of RAM, 4 gigs of RAM, 1 CPU, and a really slow disk. Thanks, Azure. What do you think I'm going to abuse the most? The RAM. I have 1,000 podcasts, 1,015 episodes over 20 years. I've got 4,000 blog post entries over the last 25 years. What do you think I'm going to do with all that RAM, friends? I'm going to cache it all. Do you know, anyone want to guess what it costs me in memory space to cache every blog post that I have written in the last 2 decades? Guess. 300 megs. I'm watching people out there with WordPress, where you ever visit a WordPress blog and they're like, database connection, database refused, sorry. Why are you going to the database? You have 10 blog posts on your website. My entire website is a bunch of XML files in a folder, and I cache it all. You do not need to go back to the database for these things. That's just architecture that has always been that way. So fast forward, remember this? Those are the days. If anyone's never seen that, be happy, because it was bad. So now we're over here, and then we learn JavaScript. This is a flow chart on how to learn JavaScript. And we all know that the web is very simple. So we're in a world now where we're being told about agentic systems, about Azure OpenAI and all these things. I am arguing that more than ever, a basic understanding of what's going on underneath matters more than ever. If you are a senior who understands things, you are going to get accelerated. And if you are not learning and paying attention as an early in career, you're going to get left behind, and you're always going to wonder how that magic carriage arrived to pick you up and who was driving it. You'll never really understand Uber, and you won't be able to design it. So now, this demo is insane for no reason. All right, Altair. We're going to plug it in. And then we're going to make it so you can see it using a new high-tech technology called this webcam. I brought this webcam all the way from the US and these manuals because I don't know what I'm doing. And I wrote down the instructions. And I thought it'd be cool because I wanted to send the bytes on the front of the Altair up into the cloud so that I could remote the front end of the Altair. So I was like, how do I get those bytes if I'm going to be seeing the memory space there? Well, I could connect wires to it and maybe have like an Arduino or something and like look at the wires, but that would maybe slow down the voltage. It would change the behavior of the Altair. So I thought maybe I would just use a webcam and machine learning because that would be stupid, right? And then I need to figure out how to put it on the network. And I'm like, do I do HTTP? Do I make an API? Well, this is streaming. Do I use Kafka to send 8 bits at a time? I don't know. I thought then maybe I'll just pack a really tight data packet and then just use UDP. So I'll just make an unlimited UDP stream, except that's going to be on my local subnet. So how do I get it off my local subnet into the cloud? We could use like SignalR and like pack it like an XML maybe just to be obnoxious and throw that up into the cloud. I could use something like ngrok or Tailscale to go across the network, transverse the network. Then I need a JavaScript client on the other end to be able to see all of that data and decode it. And then I need a Python front end in order to see the screen, calibrate the brightness of the camera, right? You kind of get where I'm going here, right? Like, that would be stupid, right? It is. First thing I'll show you, I have how much time? 6 minutes. There's no way this is happening in 6 minutes. First thing is to show you that I can connect to it. I put in my terminal here Altair, because I thought it was as important as PowerShell, but not as important as Ubuntu, so I kind of like put it at the bottom there. And then I made it retro graphics. Okay, so I wrote down the switches. 1, 0, 1, aux 2. I don't know what I'm doing. Okay, I just want to call out that I did do the retro font. Okay, I can go, let me see here, stop up, aux 1 up. And then I can set up the disk. And mount games. And then 0001. Exit, exit. So I'm setting these loader addresses. And then aux1. You see how it's coming back slower? Oh, is that Star Trek? So then I've got Microsoft Basic. I've got games at the command line that I can play. Othello, Ladder. This is a game from 1982. You see how it's coming back? So I'm talking to this over a serial port over to the machine. And then if I want, we can go back here. You can see that these addresses are all lit up. We can set that up to play different games that are directly on the screen. So I'm going to reset with stop up and reset. And then set it to Pong. Or we can unplug it, plug it back in again. Okay, so there's Pong. So you have to press up on 8 to Pong it back. So you get the idea, right? So let's send that out to the internet, because that would be stupid. So we're in a folder called Altair Cam. First thing I need to do is, it's the wrong screen. Bro, I need to fix that. How do I switch cameras? Okay, I know. I forgot I have 2 cameras. There we go. That's the one I want. Camera 0. That's camera 2. Camera 1. Okay, that's the one I want. Okay. Calibrate. To identify which camera index. I wrote this last week. Do I have to opening camera configuration? No, that wasn't it. No! So I wrote a bunch of markdown file. What's that? The issue is that I have 2 cameras, and I have to go into this camera index file here. So if we go to code, and we go into config, camera, I want camera index 0. I can see the confidence level the audience has is quite low right now. Okay, now we have to click on each LED. Only got to do this once. Isn't this exciting? People are like holding the little red card, getting ready to put it in the bowl outside. Okay, so we've marked each of the LEDs, and we can't move it or the camera now. So then I hit save. So now I've saved the camera positions in space. Okay, and those are now saved to an XML file. I was just kidding, it's Jason. So now I'm going to open up 2 more PowerShell windows because you don't have enough PowerShell windows. And each one is going to run a different thing. So now we're going to run demo, and I'm going to pick emoji because it's awesome. They're very good at clapping exactly when they're supposed to clap. Okay, so that's a view of it happening locally. And you can see them turning green, and you can see the confidence level for each LED. Okay, so now we're going to have a network bridge that's going to then spit this out over WebSockets. So now it's receiving the packets over here of a mask of the stuff. And then we're going to run ngrok on port 8080 and then send it out to the internet. Oh, I've bumped it. Everything's fine, just don't bump it. So I showed that to my boss, and he said, "That's really stupid." I said, "Is it? I think it's fucking awesome." For no reason, then it's awesome. A lot of that was vibe coded because it doesn't matter. But I don't think that an early in career person could vibe code that unless they saw the previous hour of the talk. There's a lot going on there. There's Naturversal, there's machine learning, there's Python, there's ngrok, there is a lot. But I was able to pull it off. How long do you think that would take for you to write if I gave you the spec? No, it's not years. You know, a weekend, a good, serious, caffeinated 3-day weekend. And you can see the parts you'd get stuck on. You can feel those parts. You know exactly where you get stuck. It'd be packing and unpacking the bytes. It'd be packing them in Python and unpacking them in JavaScript. It'd be a little off by 1 errors. It'd be the JavaScript, right? It'd be the robustness. It'd be all those things. We know that because we've done it before. But I know that. So in this case, the whole thing was coded with Copilot CLI. And Copilot CLI is awesome for one reason and one reason only. It has a cool banner that's animated. So I'm just going to run it again because it's the only thing that matters. And that right there, that banner across the top, is a callback to the ANSI art and the animations of the bulletin board systems from 40 plus years ago. There's a renaissance happening at the command line right now. And knowing that from a half a century ago has, in my opinion, enabled me to do stupid shit like this to entertain you all at Azure Dev Summit. Thanks so much for spending time with me today. One last thing I would say, if you see my boss, Scott Hunter, just casually mention that it was awesome and worth the time. Because otherwise, I got to put my time card in, it's going to be like a whole thing. Thank you all. You see this?